Alrighty, welcome everyone to day 7 of Advent to Code. Get ready, 10 seconds here starts. My lights are working again. Actually, over here. Lights there in the back, they're working again. But at any rate, day 7. Fingers crossed this ain't too bad. Let's get into it. Your all expenses paid trip turns out to be a one-way, 5-minute ride in an airship. At least a school airship that drops you off at the edge of the vast desert and descends back to Island. Did you bring the parts? You turn around and see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, the loudest time. You aren't sure what parts you're looking for. You're here to figure out why the sand stopped. The parts for the sand. Yes, come with me. I will show you. She beckons to the camel. For any bit across the sand of Desert Island, you see what looks like a very large rock covering half its horizon. The elf explains that the rock are all along the part of the desert island that is directly above Island, making it hard to even get there. Normally they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You really assumed it would be your job to figure out why the parts stopped and ask help. You agree automatically. Because the journey will take a few days, she offers to teach you a game of camel cards. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled K. The relative strength of each card follows the order, where A is the highest and 2 is lowest. Every hand is exactly one type. The strongest, weakest, they are 4 of a kind, 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, high card. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. If 2 hands have the same type, a second ordering rule takes effect, starting by comparing the first card in each hand. If these cards are different, then the hand with the stronger first card is considered stronger. Okay. And fifth. So are both 4 of a kind hands, but is stronger because its first card is stronger. Similarly, okay. Okay. To play camel cards, you're given a list of hands that are corresponding bid. Your puzzle input, for example, shows 5 cards. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid amount multiplied by its rank. Where the weakest hand gets rank 1, the second hand gets 2. Okay. So the first step is to put the hands in order of strength. All our hands are a stronger type, so it gets that. Tollings of the okay. All right. So what is So this is just a complex sort, is all this is. At least for the first part. The first part is just one big complex sort. Okay. So we're gonna do input split on new lines like always. And then we are going to map it. We need to map it to return hand. So we're going to do const parts is going to equal to l.split on a space, and then hand is going to be parts 0 with bid being parse int on parts 1 10. All right, so that's going to map it. It's going to give us our hands, and now we just throw this into one big sort function. This is where it's going to get interesting. So for each hand, we need to figure out its type. So okay. Five of a kind. Trying to think, what's the? I mean, 5 kind is they're all the same. Or this is hand, sorry, not cards. 5 of kind's easy. Can we just check that they're all equal? 1, 2, 3, 4. Return 5, I guess. Oh, yeah, that's how that works. So there you go. So now they're all equal. So that's easy. 5 of kind's easy. Or actually, what if I just did this? What if I made this? Reduce. It's going to be C. Card C. Start as that. And then we just return C dot cards. C cards C. That works, right? Oops, not that. Give it a type. So if we do that, now we have cards. So we actually can do is we can just do if cards let's do const keys of cards. If keys dot length equals 1, that means we have a 5 of a kind. Then we can do is then we can check to see okay, so then we can see we can do 3, 2, and 1 pair and 4. Okay, so what we can do is we can do keys dot reduce. This is gonna be const max pair equals that. Keys dot reduce. So for reducing this is gonna be the pairs C. And they're going to return math dot max of pairs or kind, I guess, of a kind and cards C. So if max pair equals 4, we can return 4. If it is 3, it becomes a little more complex because then we can have a full house. So we won't do that yet. If it is 2, return 2. If it is a 1, return 1. And then hard card, and return 0. So the only thing that's left now is 3 of a kind versus full house. It's a full house, so we can just do keys dot length equals 2, because if it's 2, we have a full house. And you can return, oh, I messed it up. 1, 2, 3, 4, 5, 6, or 7. Haha. 6, 5, we can return 4 or 3, 2, 1, 0. Okay, so that's how we get type. So now we can do const a type equals get type for a, b type, a dot hand, b dot hand. Okay. If a type does not equal b type, we can now just return, I believe it's b type minus a type. Might be backwards, might have to figure that out. Otherwise, we can now do a check to see if a dot, we can do const a cards equals a dot hand split and b cards. And so if a cards 0, I'm also gonna need a map. It is this. So a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 12. King 11. Queen 10. Jack 9. 10, 8. That's intuitive. 9, 7. Oh, I need to make these strings. It's not gonna, yeah, just best to do it like this. Nine, 8, 6, 7, 5. Keep going to do that. 4 or 7, 6, 4. I count these correctly. 5, 3, 4, 2, 3, 1. I did count them up. 2, 0. I did count them correctly. Okay. So we can do card values does not equal a cards reduce. Yeah, we're gonna do this. I could do this all the way through, but I'm not. It's gonna be a lot of copy pasting. So instead, I'm gonna do a reduce. So this is gonna be card, and then it's gonna be, or it's gonna be, sorry. Return val, I guess. Yeah. Return val, card, and index. If the return value does not equal 0, how do I put that there? What did I mess up? There we go. That's fine. I was like, okay. A string. Oh, I gotta make the type on this dumb E number bit. There we go. Okay. And then what it's going to do is it's going to return this. I hope. Okay, and that's going to be value. That's going to sort all of these. Let's just console log this. That actually looks correct. Okay, that actually looks correct. In which case, then, what's it asking? Each hand's bid with its rank. Okay, so then the real answer is a reduce on. This is gonna be some. Sum with hand and index to get the rank. 0, and we're going to return sum plus bid hand. I had to think about that. Hand dot bid times reduce also has the array, doesn't it? Times array dot length minus index. Huh? Oh, because I see. I see. Back. Okay, hold on. Oh, I messed it up. Oh, okay. Some hand index array. Right? Sum plus hand dot bid times array length minus I. Bid's a number. Operator can be applied between hand string. Bid's a number. Index. Oh, I didn't put 0 there. This could be off by to rank 1 to 5. Okay, no, that's right. Okay, but not right. All right, test input time. What's going on here? What is going on? I get 6, 4. 4. I got the answer. 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, 6, 4, Uh-oh. Unfortunately, I think that means that something... something's not right here. Both forward kind hands, but it's stronger because his first card is stronger. These are all... cards are stronger. 3s. These seem to be all correct. Is it because I did 2 pair and 1 pair? Oh. I see. That's why I had that. Okay, so no, it is this. This is wrong. Keys dot length is 3. That means that's a 2. Otherwise, that's a 1. I wonder if that will change my answer. It does. There we go. Okay. Alright, that was my issue. Alright, so to make things a little more interesting, the alpha introduces one additional rule. Now, J cards are jokers, the wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. The other cards stay in the same order. J's cards can be timed to be whatever card is the best for the purpose of determining the hand type. For example... Oh. It's actually not hard. Actually, no. That's pretty easy. Okay, so this is going to be... symbol... Part 1... Card values... Okay. We're going to copy... I'm doing this because it's going to be all copied over. Okay. All right. Okay, so there's part 1. That goes away. Part 2 card values switches it up because now the J is down there. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Part 1's actually sorted. Get part 2 type. And this is part 2. Alright, so it's actually not too bad. So what I can do is I call get type. I also need to know the count of jokers. Equals cards J 0. Because what that means is... Actually, I don't know why I just didn't... I don't know why that's... Don't ask me why like that's like that. Okay. 5, return 6. So what happens now, max pair plus Joker's amount equals 5. Max pair plus Joker's amount is 4. Plus Joker's amount is 3. The key length, this is where it gets harder in here. But I can do all of these real quick. So the hard bit now becomes dealing with full houses. Yes. So I guess if it equals 3, or no, keys at length minus Jokers. Minus there. I think this gives us part 2. I think. No, so close. It's something that's the problem is the Jokers right now. I got the answer correct again. What did I do wrong? Is it because I'm counting, because the Joker could have a 3 of a kind with Jokers, and therefore I'm adding 3 Jokers to 3 max pair? I bet you that could be it. Call this old max pair, and if I do const max pair equals do I just have to exclude Jokers? I think it's just to exclude Jokers. I think that it might just be that. 25063. I think it might just be excluding Jokers. No. It's gotta be something to do with the Jokers being in there and causing conundrums. Oh, because I'm using part 1 card value still. That'll do it. There we go. Yeah, it took me a little bit longer. I should have. Not too bad. Not too bad. I don't really. This this code's kind of a mess. All right, let me try and clean this up, make this somewhat legible or just a little bit better, and we'll go over the solution in just a second. Alrighty, went through, cleaned it up a bit. I really kind of condensed some things down and reorganized it a bit. We still have the 2 different card value table, one for part 1, one with part 2. I condensed I kept the 2 different get part types. I condensed some stuff like the count cards. But I kept these 2, and then I condensed the sorting down to 1 function, just 1 get sort function that takes in the part type and the card values that was shared between them, but they just use different get part types and get card values. So now those are passed in through the sort here. They also condensed the parsing split that out to be its individual one. Then they're run through these here, like so. But anyways, let's go over how this all works. So today's problem, we are given this input, which is a bunch of card hands, and we have to figure out how powerful the hand is. With that, we're given criteria. There's 5 of a kind, 4 of a kind, 3 of a kind, 2 of a kind, or a 1 pair, 2 pair, and full house, and then also the high card. So there's those 7 different kind of outcomes. To do that, first we start by going through and parsing our inputs. It's just splitting new lines, and then splitting to get the hand and then the bid value, and kind of cleaning it up to a nice little object here. And then part 1, part 2, I'm going to kind of do it together because they work basically the same, just a small difference. What happens is we take those parsed values and we throw them into a sort. This sort, all it does is just go through and gets the part type for the one hand, and it gets the part type for the first hand and the second hand that are being compared together. The way this works is for part 1, we simply get all the cards, we count how much of each card is in that hand, so we basically just go through a big reduce that splits the hand into individual cards, and then smash them all together to get the count of each card, so how many kings, how many aces, jacks, queens, or what have you of that hand. And using that, we can know if we have a 5 of a kind. If we only have, or from that, we can get the max number or the highest occurrence of any card in the hand. If the max occurrence is 5, we know we have a 5 of a kind. If it's 4, we know we have a 4 of a kind. If it's 3, we now determine between a full house and a 3 of a kind. If there's only 2 keys, we only have 2 cards in our hand, that means it's a full house. Otherwise, we have 3 of a kind. Same for 2 pair and 1 pair. If we have 3 keys in our hand, or if we have 3 different types of card in our hand, that means we have a 2 pair. If we have not that, we know we have 4 pair. Otherwise, or we only have 1 pair, so I should say. Otherwise, we return 0 for a high card. Part 2 works very similar in the fact that jacks are now wild cards, so we ignore the jacks or the jokers from that pair. But then because they can be anything, we can just take whatever the highest count of cards we have is. So we have 3 kings and we have 1 joker. Well, that joker automatically goes with those 3 kings to give us our max we could have, which in that case is 4 of kinds. The jokers just automatically get smashed with whichever card we have the most of. In the case of the full house in pairs, we still do that. We still throw all the jokers with the highest, or the highest count card, but then we subtract those jokers, or we subtract the, actually, does that even need it now? Keys, no, because it's not part of max pair. Yeah, so we subtract the fact there is a joker from the keys, and then if we still have 2, we know the jokers will automatically kind of filter out. So that's how we still kind of get that logic. But again, same as part 1, part 2, just the jokers play different roles and how that works. After we get those types, though, we simply check if they're equal. If they're not equal, we return B minus A, just like normal sorting does. That's done. Otherwise, now we have to go through and we do this nice little reduce here to figure out where the first cards are that aren't the same, and then we subtract their values as determined again by our nice big card values table, and that'll give us a nice sorting of these, to which we can throw through this reduce to simply calculate its rank, which is the total amount of cards minus the index in the sorted list, multiplied by its bid, summed up. And that's part 1, part 2. Pretty straightforward. Again, it's just very fancy sorting. So nothing too special, just the hard part is this get part. If you can figure out this get part, the rest of it is really simple. But at any rate, that's it for me for day 7. Hopefully you guys enjoyed. I'll catch you guys all tomorrow for day 8. Peace out.